Hi, my name is Amit Pandey. I work with Vedic Software Lab, India, and I'm taking you through the topic polymorphism. It's a OOPS concept, and I will show you how to understand polymorphism. Let's go through the presentation here. Basically, what does polymorphism means? Polymorphism, if you have studied the book, it says many forms. What does the many form means? Basically, if you look at any object in the nature, it has a ability to behave differently depending upon the input. Let me take an example here. We all have hand. Okay, our hand has a base class having the functionality of holding the objects. When we were kid, we could only hold objects in our hand, but when we went to school, we had to override this feature with another feature called as writing through pen, holding in the hand. So we inherited from this base class the functionality of holding and overrided it into the derived class, where we have overloaded the function over holding with writing capability. Now when we have an object of base class, we have the ability to hold, and when we have an object of derived class, we have the ability to write. So depending upon our requirement, we make object and take use of it. In C++, pointers are important to implement the polymorphism, that is late binding or dynamic polymorphism. We have two types of polymorphism: static polymorphism, that is early binding, and dynamic polymorphism, that is late binding. Let's see what is static polymorphism. Static means what is available throughout the life cycle of the program. This type of polymorphism is available through the entire life cycle of the program, and you can access them anytime you want. So what are the ways of having static polymorphism? One is function overloading. Now what is function overloading? When exactly the function matches in function name within a class but differs in number and type or type of arguments, that is called as function overloading. It's a compile time decision because the compiler will decide which function to be called based on the parameter. Now input is parameter. What is the input here? The input is the decision making happens based on the parameter of the function. Okay, return type has no role as its runtime activity. Within a class, some functions have same name and they are called as overloaded. They must differ either in the number of arguments or type of the argument. Now let's come to the dynamic polymorphism. This is achieved by virtuality. What does we mean by virtuality? Virtuality means which is not the reality. In a real situation, if you look at our hand is performing an work, okay, but this is not a compile time feature, it is a runtime feature. So we must have a pointer pointing to an object either by upcasting or to the class pointer pointing to the object of the same class, say base class. So we have a base class pointer pointing to an base class object, or we have a base class pointer pointing to an derived class object. So if pointer is pointing to a derived class object, the function that will be called is the derived one, whereas if the class is the object is of base class, then the base class function will be called. Now functions should match in the number, type and name of the function. So they should exactly match to each other in the base class and the derived class. The function should have a virtual keyword in front of the return type mentioned in the function declaration. Now I said input is object. What do I mean by input is object? Actually, if you don't declare the function as virtual, the pointer will decide which function to be called. So if it's a base class pointer, it will always call base class function. If it's a derived class pointer, it will call the derived class object. But if we use virtual keyword, then object become the decision maker, because the input here is object. So depending upon the input, the function is called. Now we need to have a base class and derived class relationship here. I mean, inheritance is must. And there is a concept of vtable and vptr in C++. What is vptr? When you declare a function as virtual within a class, which is your base class, then the compiler will insert a vptr inside the class that will be embedded inside the class as an attribute. This vptr is, and there is a concept of vtable. Now compiler will also create a vtable which holds the address of all the virtual functions mentioned inside the class. There is one vtable for one class, and there will be vptr for every object. Every object will have one vptr because it is an attribute of the class, so it will be holded by all the objects. So I have a class A, then it will be having a vptr into it, and this vptr will be pointing to the vtable of the class A. So at the when we create the object through new keyword, the class will at runtime the vptr will be initialized with the address of vtable, and now we know which vtable to be called depending upon the object. Suppose the object is of the derived class, so it's a derived class vptr, and it will be initialized with the vtable of the derived class. If vptr is inside the base class, then it will be initialized with the address of the vtable of the base class. Now I've initially taken an example of hand. So hand works like a virtual one. What is the input here? Input is the object. If the object is to hold, we will hold it. If the object is a pen, we will write it. So depending upon the object, we are performing the job. In runtime, we actually don't know it's a derived class or a base class. The base class has the functionality of holding the pen, and derived class has the ability to write through pen. So as we move on and learn into practices, we keep on deriving new classes from the upper one, so that we can add new functionality, and all the functionality is available depending upon the input. Thank you.